Hi friends, you're welcome to another live class with Dr. Vivian. So today I want us to learn everything about radical. All right. In some place it is called sword, and in some place it is called radical. Okay. So let's talk about expressions, operation with sword. What is sword? Sword simply means square root. This is sword. All right. This So these are called sword radicals. All right. So what are we going to do is I'm going to show you the laws of radical. There are some laws governing this radical. Then if you know the laws, you know how to apply it. We talk about addition of radical, subtraction, division of radical, multiplication of radical. And then we're going to talk about rationalization of radical sword. All right. So that's what we're going to do today. So I've showed you what it means. When you see a sword, you know it's something like this. All right. So let's talk about the laws of radical. Like I said earlier, radical simply means sword. They are the same thing. It's just like saying parentheses and brackets. They are the same thing. So whether I call it radical or sword, you're talking about exactly the same thing. So let's look at the laws of radical. Okay. So the first law we have on radical is we have this law, square root of PQ is equals to square root of P multiplied by square root of Q. All right. So I'm just not going to show you the laws. I'm going to show you the law and I'm going to put it in numbers. Okay. So we can say if we have something like square root of 50, okay, and this is 50 divided by 2 will give us 25. And we have something like 25 times 2. All right. So this is our P and this is our Q. So this can be written as square root of 25 multiplied by square root of 2. So that is what this first law of radical is talking about. That if you have multiplication of two numbers in the square root, under the square root, you can separate them like this. That is what the first law of radical is saying. Okay, so that is first law. I'm going to clean it and show you the second law. So the second law states that the second law of radical states that square root of P all over Q is equals to square root of P all over square root of Q. All right. So the first law has been settled. This is second law. It says that square root of P all over Q is equal to square root of PQ. So let's take for instance, okay, square root of 25 all over 9 is equals to square root of 25 all over square root of 9. And this is equal to, all right, and this is equal to 5 all over 3. So when I'm checking to see whether you'll see what I'm doing. That's why I go back to check. So that is what the second law says. Whenever you have a number like this, all right, you can separate them with individual roots, and then we get our answer. All right. Let me show you another example to that effect again. Another example is this. Let me take it from here to this part. We have square root of 90 all over square root of 10. Okay, so this is equals to square root of 90 all over 10. So this will divide here, and we have 9, and the answer is 3. So here, this is correct. Based on the law of radical, you can do this and get the answer we are having there. All right, so I'm trying to explain it to you so you understand it perfectly. So we solve something very difficult, you understand where we are coming from, where we are heading to. All right, so that is on the second law of radical. So talk about the third law. All right, so the third law says that square root of p plus q is not equal to square root of p plus square root of q. All right, this is as simple as it is here now. Because you have p plus q, you can't say it's equals to square root of p plus square root of q. Let's take, for instance, we have square root of 25 plus square root of 20, square root of 25 plus 25, okay, is not equal to square root of 25 plus square root of 25. Now, I'm going to show you that these two are not equal, all right? Let's solve this individually and solve this individually and get the answer, okay? So here, this is equal to square root of 25 plus 25 is 50, all right? So 50 divided by 2 gives us 25, and this is equals to 25 times 2, all right? Using the first law, we can separate them, all right? You can separate these two, and we have root 25 times root 2, all right? And we know that root 25 is 5 and root 2, so this is equals to 5 root 2. So that is the answer when you solve square root of 25 plus 25, then that is on that part. Then on this part, 25 is 5 plus 25 is, square root of 25 is 5, and that is 10. As you can see, the answer, they are not equal. All right, so the answer is not equal. So that is what the law of radical 3 is saying, that the square root of p plus q is not equal to square root of p plus square root of q. So I've shown you that they are not equal. Then you have to know that, okay? So go to the next rule, the fourth one. Please help us share the live section. Help us share the live section, all right? You can help us share the live section, please. So the next law is the fourth one. Square root of p minus q is not equal to square root of p minus square root of q, all right? Just similar to what we did before, and therefore we'll just leave it unattended without adding more problem to it. So that one is very easy and understandable, okay? So that is the fourth law of radical. So please help us like the live section, help us like the live section and share it, all right? So if you know the law, it will make it easy for you to solve the question itself, because the law of radical will guide you on the way forward, all right? So let's talk about basic forms of sword. Now, there's something I want you to just know. You can only call a number a sword when you have a combination of a perfect square and a non-perfect square. Take, for instance, what are perfect squares? Let's start from there. Perfect squares. Now, numbers that are perfect squares are those numbers when you take their square root, you get a whole number. All right. If you take square root, let's say 4. If you take square root of 4, you get 2. And 2 is a whole number, right? So 4 is a perfect square. If you take square root of 36, we'll get 6. So 36 is a perfect square. All right. Now, if you take square root of 3, if you do that, you get 1 point something something something. So 3 is not a perfect square. So a perfect sod is a number that have combination of a perfect square and a non-perfect square. Take for instance, we do square root of 12 is equal to square root of 4 times 3. So 4 here is a perfect square. This is not a perfect square. So here is where you know that you're going to get solve it, because this is already a solve, the radical form of the question. Okay, hope you're understanding what I'm saying. So I'm just trying to show you basic forms of solve. Okay, now let me list solve for you and the ones that are not solved. All right. Now, square root of 6. You see this square root of 6? You cannot get a perfect square from here. So this one is a solve, right? Square root of 5. You cannot get perfect square here. So this one is 1. We have root 3. We have root 2. We have root 7. We have root 11. All right. So these ones are among the sorts. Now we have root 4. It is not a sort because this is equal to 2. All right. When you have square root of 81, and this is 9, so this is not among. So these are the perfect form of sort. These ones are not, because when you convert them, they become whole number. Okay. Now this one is among. We have 3 root 2 because of this root 2 here. So this one is a sort. You understand? I hope you understand what I'm trying to explain to you. Okay, so that you see how you identify a sort. Hi, Casey and Frederick. Thank you for joining us, all right? Hi, how are you? So that is it. Let's go into the main aspect. These are the basics. So if you know this aspect, you know it's easy, it will be easy for you. Okay, so let's talk about similar sorts. Similar sort. Now the question is, when are sorts said to be similar? A sort is said to be similar when whatever that is under the square root is the same. Okay, let's say I have 3 root 2 and x root 2. Now they are similar because the square roots are the same. All right, that's where you consider when you're talking about this similarity of sort. You look at what is under the square root. Okay, we have 3 root 5 and 8 root 5. They are similar. All right, so because we are concentrating on this. When we say 2 root 3 and root 2 and root 3, they are similar. All right, when you have all that, they are similar sorts. So these sorts are similar. So we talk about the non-similar sorts. Non-similar. When we talk about the non-similar sort, okay, if you have a root 4 and 5 root 2. Now these ones are not similar because this is root 3 and 5 root 2. They are not similar. because the salt are different, so they are not similar. Okay. Then we have n root x and x root n. Now these two are not similar because this is x here and this is n, so they are not similar. All right. So that is to say, if you have 5 root 7 and 7 root 5, they are not similar. Now, when they are considered to be similar is when whatever that is under, they are the same. This and this the same, they are similar. When they are different, they are not similar. I'm showing you this so that you see it. Let me check whether you're even seeing this perfectly well. All right. So great. That is how you know similar and non-similar sword. Right. So let's go to the next one. So go to simplification of sword. Please, when I say sword, know that I'm talking about radical. The difference is where people are watching from. In Nigeria, we call it sword. In some foreign countries, they call it radical. So they are the same. All right. So we'll talk about conjugate sword. So when we talk about conjugate sword, it's just trying to, when you talk about conjugate sword, all right, we are trying to, let me show what it means. We have 3 minus root 2. Now, the conjugate of 3 minus root 2 is 3 plus root 2. What did we do? We just changed the sign. So when you are giving a sword and say, give me the conjugate of it, if it's negative, you have here, you change it to positive. If it's positive, you have here, you change it to negative. That is the summary of what conjugate means in sword. All right. So that is to say, if we have root 5 plus root plus 3 root 7, its conjugate is root 5 minus 3 root 7. All you did do is just change the sign and you get the conjugate. So if I'm to read out what I wrote about it, I said conjugate swords are 2 swords whose product results in a rational number. In an expression containing difference of 2 squares, it is known that x plus y bracket x minus y is equal to x squared plus y squared. All right. Is equals to, yes, this like in algebraic identity, let me not just get you confused. It simply means that let me put it in a way you understand it. All right. The conjugate of 3 minus root 2 is 3 plus root 2. That's the summary of everything. Because in mathematics, sometimes you as a teacher trying to express yourself may not really do it the way your students understand. So instead of getting them confused, trying to understand you, we go straight to the point and I tell you, this is exactly what I'm talking about. And that will save the students a whole lot of stress. So let's go to simplification of sorts. Now, this conjugate of sorts, where you meet it again is when you're solving when you're rationalizing sorts. That's when you meet conjugate. We just mentioned this so that you know about it. By the time we get to where we apply it, you now remember that you know it. Okay. So let's go to the simplification of sword. Okay. Let's go to simplification of sword. Just like the word says, simplification. Just like when you simplify in a radical, simplification simply means to break down an ambiguous number to a smaller form. That is what it simply means. A simple English. All right. So when you do that, you say swords can be simplified either in their simplest form as a single sword. So that is how you can convert it from a bigger one to a smaller one, or you can even convert a bigger one to just a single sword. That's what it simply means. So take for instance, example, we are going to solve like example 3 so that you understand what I'm trying to say. We say square root of, all right, square root of 72. Okay, so we want to solve this. We say what is square root of 72? Now, there's no square root of 72 that will give us a whole number. So this is a combination of a perfect square and a non-perfect square. Now I'm going to show you a more easier way to do it. After showing you that, I'll now continue so that even when you're given a number that you cannot easily remember how to get it, you can easily use this step I'm showing you now to do it and get it faster. See 72, we are going to divide. Write 72. We are dividing by 2. All right? 72 divided by 2 give us 36. Now, if you know, we know that 36 is equal to square root of 36 is 6. So 36 is a perfect square. If you know, at this stage, you're already done. But when you don't know, keep dividing. You get the final answer. Let's go. So we divide by 2 again. 36 divided by 2 will give us 18, right? Divide by 2 again, we get 9. Divide by 3, we get 3. Divide by 3, we get 1. All right? So have you seen it? If you multiply everything we have here, we get here. See, 3 times 3 is 9. 9 times 2 is 18. 18 times 2 36. 36 times 2 is 72. Now see what we are going to do. Since we are taking square root. Square root means to pair. Like you pair this and this, this and this. This times this will give us 4. This times this will give us 9. 9 times 4 is 36. 36 times 2 is 36 times 2 is 72. So this is what you're going to write, right? So those ones that we have in pairs, we're going to write it 1 1. So we have 9 times we have 4. Then we have 2. All right. So using the law of radical, we're going to separate it. Okay. So we're going to separate it. I'm just showing you the easiest way to solve it when you cannot figure out the perfect square off by heart. All right, but if you know the perfect square, it's very easy. So this is equals to, now following the first law of radical, which says that square root of PQ is equals to square root of P times square root of Q. Now, so following this, all right, this will now give us root 9 times root 4 times root 2. Okay. So root 9 is 3 times root 2. Root 4 is 2 times root 2 is the radical. 2 times 3 is 6. So that is 6 root 2. And that is the answer. You see how easy it is. So that is to say, if you know that aspect, like if you know, now from here, let's make it easier. You can solve it either this long process or you solve this short process. This short process saves time. In mathematics, learn how to save time. If you can think faster, best. So square root of root 72 divided by 2. 72 divided by 2 is 36. So we now have root 36 times 2. Separating using this law. This is root 36 times root 2. And root 36, we know is 6 already. So that is 6 root 2. If you know this, you solve this. If you know this way, you solve this way. Any way you choose to solve, they are very correct. All right. I'm just showing you the two process so that when you're kind of confused on how to go ahead, you solve using the other process. This is longer, but it's correct. This is shorter, it's correct. So if you can try this, use this shorter method, it's better. So that is on example 1. So we're going to solve example 2. Example 2 says 2, which says solve square root of 45. All right. So that is easy. Now we know 45 divided by 5 will give us a 9. Will give us a 9. So that is square root of 9 times 5. All right. And from law of radical, this is root 9 times root 5. Square root of 9 we know is 3, and that is 3 root 5. On the shortcut. Then on the long procedure, okay, we do square root of, on the long procedure, we draw a line, we write 45. Now, 45 can be divided by, the smallest number can divide for 2, cannot divide it. 3 can divide it. So if 3 divide 45, we have 15. Now, 3 can divide again. We have 5. Now, 5 will divide, we have 1. So we have paired, and we have 3 into 2 places. We paired it, and 3 times 3 is 9. And that is still square root of 9 times 5. All right, that is exactly what we have here. So if you solve it from here, you arrive at the same answer. You see that it's very easy. It is very, very easy. Please, if you're not following this channel, follow us. You learn amazing math classes. We do live classes every 12 p.m. Monday to Friday, 12 p.m. We do 1-hour class, and in the evening section, we also do classes. So that evening session don't have a specific time, but for now, this is 12 noon and it's working. All right. So we're going to solve more examples. So the next example we are going to solve is let me just give you off. Let's just say we are going to solve root 88. Yes, let's see what root 88 will give us. All right, so I don't know any number you divide with this to give you that number. So we're going to do the long procedure to see if we can get numbers. All right, so have 88. Let me check whether you're seeing it. Okay, good. So we have 88. Okay, we have 88 to divide by 2, and we have 44. We divide by 2, we have 22. We divide by 2, we have 11. And 11 is a prime number, so you can't divide further. So you can't divide 11 further. Okay, so we have 11, and we have 1. So we only have this pair here, and that is 4. Okay, so in the whole basket, you have 11 times 4 times 2. So 11 times 4 is 44 times 2 is 88. So it's correct. So this is only perfect square we have there. So what are you going to do? We will do square root of 4 times square root of 2 times 2. 11 times 2 is 22. Okay. And if you do that, you have 2 root 22. And that is the answer to the question. You see it? Because this cannot be divided by any number to give us a perfect square. So the only perfect square where we are able to pick from here is 4. So this answer is perfectly correct. That is how easy it is to solve radicals. All right. So we're going to solve another example. Now, this example, this time around, we are not going to simplify from a full radical to, we're not going to, okay. So we're not just going to make it, put it in a simpler, you know what we did now? We just reduce this to a simpler form. Now we're going to move from a simpler form to a more stronger one. Let me just show you all this grammar. Let me show you what it means. We are giving example 1. We are given 3 root 2, and we are asked to simplify it. Okay. Now this sword now is in a simpler form. So we are going to make it to have make it a single sword. Yes, make it a single sword. Put it together so it become one sword. How do we do that? Now, whenever you have something like this, all you need to do is just this one, square it and put it in a bracket. That is 3 square is 9 times root 2. You see? Now, when you simplify this root 2 again, root 9, you get 3. You see what I did? All you need to do is just to open it, you have root 9 times 2, and that is root 18. And this is what all the grammar I'm speaking is all about. So I'm moving it from a simpler form to a single sword. That is what I'm showing you how to convert from a simpler form to a single sword. All right. So what are we doing next? So I want you to solve just one example for me. Let me be sure that everything I've been speaking, you are understanding it. All right. So solve this simple one for me. Simplify 20. So solve this. Let me see your answer, please. Solve. Let me see your answer. If you understood what I taught you, or maybe you're following what I'm teaching, please solve that. Let's see. Let me see your answer. I want you to tell me your answer. Let me see. Drop it in the comment section. Then I will just solve and cross-check and be sure that you are right. Okay. So let me solve it. All right. So this is equal to square root of, if 2 divide, we have 10 and 2. No, not backward square. If 4 divide, we have 5 and 4. So we have 4 times 5, and that is 20. All right. So this is equal to square root of 4 multiplied by square root of 5, and this is 2 root 5. Okay, and that is the answer. Is that easy? All right. So I want you to always know that mathematics is so easy. Mathematics is a very, very, very easy course. All right. So let's talk about addition and subtraction of sword. Okay. Addition and subtraction of sword. All right. We talk about addition. And subtraction of sword. All right. Sword or radical, the same thing. They are the same thing. The difference is your location. All right. So talk about addition and subtraction of sword. Okay. So example 1 is just as the name means addition and subtraction of sword. What's the only thing you have to bear in mind in the process of adding and subtracting sword is that if you're given a sword in a single form, you're first of all going to convert it to a simpler form before you can now do the addition or subtraction on the given swords. All right. Let's say, for instance, you're given sword 50 plus sword plus 3 sword 8. All right. You see that these two swords, this one is not in its simplest form, neither is this in its simplest form. So first of all, you're going to put them in this simplest form before you can now add. Okay, it's that simple. So like if we divide 50 by 2, we have 25. That is 25 times 2 is 50. All right, 3, and we have the sword here. Divide here by 2, we have 4. So 4 times 2 is 8. Okay? So I'm going to apply the law of sword here. If we do that, we have root 25 multiplied by root 2 plus 3. We will apply law here again. That is root 4 times root 2. Okay? So root 25 is 5. Then root 2 plus 3 times root 4 is 2 times root 2. Okay? And that is 5 root 2 plus 2 times 3 is 6 root 2. So if you do 5 plus 6 is 11, and it's root 2. All right? So the answer is 11 root 2. Okay? The correct answer is 11 root 2. Please, if you're enjoying the live class, help us, give us a thumbs up, like the class, and help us share. All right? Help us like the class and share. Okay? So let me give you small classwork so that you do. Let's see. Let me give you small classwork. Okay? So classwork, please solve. Let me see whether you're even following me. Classwork. Okay? So this is on the classwork. Solve 7 root 3 minus root 12. Solve it. Drop your answer. Please solve it. Let me see your answer. Let me be sure you're understanding what I'm doing. Please solve. Let me see. I need you to try so I'll be sure that you are following me. Please try something. So let me solve it. So we are giving 7 root 3 minus root 12. So looking at it, this one is already in its simplest form. We are going to change root 12 into its simplest form. If we do that, we have 7 root 3 minus, now 3. Now there is already a hint. The hint is root 3. So we are going to divide here by 3. And if you do that, we have 4 times 3. And this is 12. Okay? So we have 7 root 3 minus, this is 2 root 3. And this is 7 minus 2 is 5. All right? 5 root 3. That is how easy it is to solve that. All right? It's actually easy. It's very easy. All right? So thank you for liking. Help us share the live section. And please help us tap that love bubbles so it will be flying. Thank you. So let's solve another one. So this is the fourth question. Once we do this final one, we move other to other things. Okay? So we have 3 root 48. 3 root 48 minus root 75 minus root 75. Okay? Plus 2 root 12 plus 2 root 12 plus 2 root 12. Okay? So I'm asked to simplify this. Now looking at this, none of them is in its simplest form. So first of all, we're going to start by converting them to its simplest form before we can now add, subtract as the question demands. All right, so we'll start from 48. So I'm going to draw a line right 48. Okay, like I said, because I cannot really think out what this is, so I'm going to divide instead of wasting time. So 2 divide here, we have 2, we have 4. 2 divide, we have 1, we have 2. 2 divide, we have 6. 2 divide, we have 3. And here we have 3. So this is 4, 4. 4 times 4 is 16. So this is 16 times 3 is 48. Okay? So that is what I'm going to 16 times 3. So we have 3 roots. Okay, 3 multiplied by root 16 times 3 minus the same here, the same thing here. So since 3 is here, that is a hint that everything here is divisible by 3. So 3 divided here will give us 25. That is 25 times 3 plus 2 times. Now 3 will divide here to give us root 4 times 3. So once you get one hint, solving others is very easy. All right. If you just get the first smallest number, dividing others is very, see how easy it is. Instead of going to draw line and start finding individually, just divide through by 3 and it worked. So this is equal to 3 times. Now we're going to apply the law of first law of radical. That is here, we're going to do root 16 times root 3 minus, we do the same here, root 25 times root 3 plus 2 times root 4 times root 3. All right, that's it. To separate each radical to have their individual radical. So this is 3. Root 16 is 4 times root 3 minus, that is 5 times root 3 plus 2 times 2 times root 3. Okay, so I'm just going to 3 times 4 is 12. 12 root 3 minus, this is 5 root 3 plus 2 times 2 is 4 root 3. 12 minus 5. 12 minus 5 is 7. 7 plus 4 is 11 root 3. So the answer is 11 root 3. You see how easy it is to solve it. I hope I'm not too fast. That is how easy it is to solve it. All right. So that is on the addition and subtraction of radical. So we are going to, this is on addition and subtraction of radical. So we go to multiplication and division of radical. Please, if there's any way you need me to explain, you can ask questions. Drop your comments so that I can solve it for you. If there's any place you think you need explanation, you let me know. All right, you can drop your question. That's why if I stay small, I'll go and check the back of my camera to see if there's any question. So if you have any question, please drop your question and help us like this live section. Help us share it. All right, let more people join us and learn with us, please. Thank you. So I'm going to solve multiplication. Multiplication and division of radical. Okay, so I'm going to do division and subtraction of radical. So let's just solve something simple. So example one says, let's just solve anything we can remember. We have root 18 times root root 18 times root 27. Yeah, let me just use this. you know. Yeah. So the solution is very easy. We know 18 divided by 2 will give us 9. So we have root 9 times 2 times root. Divide here by 9, we have 9 times 3. Okay? So if we separate them, we have root 9 times root 2, okay, times root 9 times root 3. So this is 3 times, this is root 2 times, this is 3 times root 3. Okay? I hope you understand what I'm doing. Please, if you understood what I just did now, tell me yes in the comment section so I'll be sure that you are following. If you understood what I did now, just tell me yes in the comment. Just write yes in the comment section so that I can continue. If you don't understand, I repeat it again. I want you to understand. All right. You can't stay here and be watching, listening, and you don't understand. It's not fair. So if you're not, if you understood what I did, just write yes in the comment section so that I will know that you're following it. All right. Okay. So we continue. So let me continue so that you see how I concluded the solution, the question. So here we have 3, we have 3. 3 times 3 will give us 9. 2 times root 2 times root 3 will give us root 6. And that is the answer to the question. All right. So that is the answer to the question. All right. Now we solve more examples. Okay. We will solve more examples. Let's solve example of division. All right. Let's solve example of division of radical. We have root 75 all over root 25. All right. So let's solve this. Okay. If we do that, this is equals to root 75 is equals to 25 times 3 all over root 25. Okay. Using law of radical, we can separate this to give us root 25 times root 3 all over root 25. So 25 will cancel itself and an answer is root 3. All right. That one is that easy. Let me look for something that is more difficult. Okay. Let me look for something that is more, that is a bit difficult. All right. $24 and with 50. We have root 24. 24 all over root 50. Okay. So I'll show you how to solve this. I'm coming. Let me top up my ink. So to solve this, it's very easy. So here, we're going to apply law of radical, which says that The law says that square root of P all over Q is equals to square root of P all over square root of Q. Now, this our question is in this form, so we are going to put it in this form. So we have 24 all over 50. Okay, 2 can divide here. If 2 divide here, we have 12 all over 25. Okay, that is root 12 all over root 25. So root 25 is root 12 is equals to square root of 4 times 3 all over root 25 is 5. Root 4 is 2. 2 root 3 all over 5. So this is the answer to this question. 2 root 3 all over 5 is the answer to this question. All right. Hope you understood what I did. It's very easy. Now we have to convert from this form to this form just to be able to divide both sides by 2. So after we divided 24 by 2, we have 12. We divided 50 by 2, we have 25. We now took it back to its individual square. We now solve this one out by dividing 12 by 3 to give us 4 and 3. And 4 is a perfect square, which is 2. And we have our 3. 25 is a perfect square, which is 5. So that is 2 root 3 all over 5. I hope that is very easy for you to understand. All right. So I'm going to solve the next question. So I'm going to solve the next question, which is rationalization of surd. So talk about rationalization of surd. It's very important. That is where that our conjugate comes in. So talk about rationalization of surd. Rationalization of surd or radical, the same thing. Whether it's called surd or radical, it simply means the same thing. All right, it means you are talking about the same thing. Now, rationalization of surd is simply doing one thing. The aim of rationalization of surd is to make sure that surd is not left as the denominator of a given surd equation that is simplified. Rationalization simply take away that radical from being under on the denominator. Okay, so let's take for example, we have 5 all over root 3. Okay, so you can't leave it like this because of this root 3 that is at the denominator, so it cannot work. In surd, it is wrong. If you drop your answer to be like this, that means you've not gotten the final answer. You are wrong. So what are we going to do? We are going to multiply up and down by root 3, okay, just to take away this surd out. So if you do that, root 3 all over, so 3 multiplied by itself will give us 9. And this is equals to 5 root 9 all over 3. Sorry, root 9 is 3, and this is the final answer. Now, if you leave an answer in this form, you're right, because the denominator is now a whole number. So you can't leave your denominator as a radical. All right. So let me do one more question and we continue tomorrow. So we are asked to solve example 2. Okay. We are asked to solve 3 all over surd 3 plus surd 2. Okay, so we are asked to solve this. All right, now to solve this particular one, we are going to find the conjugate of root 3 plus root 2. So we're going to find the conjugate of this place. Like I told you, conjugate simply means change this positive to negative. It's very easy. So you're going to multiply up and down by changing the number we got after changing this to positive. All right, that is root 3 minus root 2 all over root 3 minus root 2. So we're going to solve them out. This times this will give us root 9. Okay, let's start from here. This is 3 times root 3 is root 3 minus 3 times root 2 is 3 root 2. All right, all over 3 times root 3 will give us root 9. 3 times minus root 2 will give us minus root 6, plus 2 times plus 3 will give us plus root 6, plus 2 times minus 2 will give us minus root 4. Okay, so here 3, the roots are not similar, so I'm going to write it as we just have it there. We can just say 3 brackets what we have here, root 3 minus root 2. Let's leave it as this, all over. Now here this is minus root 6 and here this is root plus root 6, so they will cancel out. Okay, and we have square root of 9 is 3 minus square root of 4 is 2. Okay, so this is 3 brackets root 3 minus root 2. Okay, all over 3 minus 2 is 1. So it's all over 1. So the answer is just what we have here. We're going to delete 1. So this is the answer to the question. Okay, so that is how simple it is. That is the answer to the question. Okay, so with this, we are bringing the class to the end, and tomorrow we'll continue. So tomorrow we are going to continue with by 12 p.m. tomorrow we're going to be solving quadratic equations. We'll do quadratic equation. After quadratic equation, on a good other day, we'll do exponential equation. We will do simultaneous equation. We will do linear equation, probability, any maths, secondary school maths, junior secondary school maths, as many as we can lay our hands on. We'll keep solving on a daily basis. So please feel free to follow us and join us. Make it happen. Thank you so much for watching to the end. Have a lovely day. Bye. Okay, let me solve one more example so that we'll be sure the class lasted for at least 2 hours. 1 hour, 30 minutes. So I also want to solve this particular question. All right. So to do that, we are going to start with this smallest number so that we can get the clue to this question faster. All right. So we're going to do 24 divided by 2. We have 12. Divided by 2, we have 6. Divided by 3, we have 3. Divided by 3, we have 1. All right. Sorry. This is wrong. We have 6. Divided by 2, we have 3. Divided by 3, and we have 1. All right. So we're going to do here 96 divided by 2. We have 4. We have 8. Divided by 2, we have 2. We have 4. Divided by 2, we have 12, 2, 6, 2, 3, 3, 1. And here we have 150 divided by 2. We have 75, right? Yes. We divide by 3. We have 25. Okay. We divide by 5. We have 5. We divide by 5. We have 1. All right. So there is no uniformity in this one and this ones, but this one have, look at 24 is what we have from here. So you can see, so I'm going to pair the possible numbers. Okay. Have you seen it? So that is the first thing we are going to do. Then the next thing we are going to list them out in a way under, so that we can now pick it up from here and go write it up. So here we have 2 times 5. We have 25 times 6. 2 times 3 is 6. Minus, we have root. This is 16 times 6. Okay, minus, this is square root of 4 times 6. Okay, so 6 is common. All right, so 6 is common. 6 is common. So here will give us 2 times, now this is root 25 times root 6 minus, then here we have root 16 times 6, and here we have 2 times root 4 times root 6. Let me see whether you're seeing it. Okay, good. So that is it. Now here, this is equals to 2 times root 25 is 5 times root 6 minus root 16 is 4 times root 6 minus 2 times root 4 is 2 times root 6. All right, good. 2 times 5 is 10. 10 root 6 minus 4 root 6 minus 2 times 2 is 4 root 6. And this is equals to 10 root 6 minus 4 plus 4 is 8 root 6. All right, 8 root 6. And this is equals to 2 root 6. And that is how easy it is to solve that. Understand? So is that easy? All right. So it is that easy. So that is the end of our class for today. See you people tomorrow, same time. Thank you. Bye-bye. Bye.